Today we're going to be tackling format string vulnerabilities, and we're going to work on the PicoCTF format string 1. Alright, today we're going to be doing format string 1, which is in the PicoCTF PicoGYM. Great place to practice. We'll get started here. The description reads, Patrick and SpongeBob were really happy with those orders you made for them, but now they're curious about the secret menu. Find it, and along the way maybe you'll find something else of interest. We've got a binary, the source, a couple hints, format strings, what type of binary it is. Go ahead and make a directory for format string 1, and then we will just download both of these. First we can check out what type of binary this is. That was one of the hints. It's 64-bit. Perfect. And then we'll just go ahead and run it, see what it does. Give me your order, I'll read it back to you. Okay, so it looks like we have a little bit of control here. We'll check out the source code in a second. Just type in, I want a burger, please. Here's your order, I. Okay, so it must stop reading after a space. That's all right. Go ahead and open up this source code and take a look at it. We've got 4 things here. We've got secret 1, secret 2, and the flag, the buff. We read in the secret menu, read in the flag, read in the secret menu 2, go ahead and ask for the order, read in our buff, and we print it out. So we have direct control over the printf. Obviously it's a format string vulnerability, so we would, but we can do whatever we want with that. I think that the goal will be, because the flag is read in before, stack loaded here, read in with this fgets onto the stack. We'll just read the flag directly right from the stack using our format string here. But in order to do that, we're going to have to look at the binary, and we'll just go ahead and grab the dump of that. So what I like to do when I read through this is actually look at it side by side. I find that to be helpful. So we'll go ahead and make 2 columns here, look at it side by side. In order to read it directly off the stack, we're going to need to know where it is on the stack. So that we can build out our format string. So reading through, we have a couple of fgets, and that'll be the way that we tell what we're looking at here. Going down to main, first we open up the secret menu. We go ahead and call fgets from the secret menu. Open up flag, fgets on the flag. So this one should be for the flag. This is the flag, and then let's see, there should be one more fgets. Yeah, and so this is the final one for the secret 2. Perfect. Okay, so on the stack, this is going to be our flag. It's read into RAX, but passed into RDI from RAX before that. We see that that is the first argument here for the flag, and then it should be 64, which is OX40 here on the ESI, and then finally FD should be read into RDX, which will be the 3rd argument. A little primer on the way that arguments work on the stack is that for, let's say printf, because that's what we're going to be working at here. Our first one is passed into RDI, second one RSI, then we have RDX, RCX, R8, and then R9. The rest of the arguments that you might possibly pass into printf, because as you know, you can put in as many as you want, will be put right onto the stack. So this will be reading right off of RSP, or where RSP is. This will be reading RSP like +8, and again RSP +16. And that's how it works. So essentially what we do is we're going to want to get some value from the stack, and we'll be able to control which argument that is. In order to do that, we need to understand what the stack looks like. So the stack looks like, we'll start off at the top. We push our old RBP onto the stack, and before that, obviously, there's the return pointer, or this is the return address. And then we push the old RBP on. We subtract 4D0 from the stack. You can see that here from RSP. Subtract 4D0. So we know that that is where RSP is. That'll be equal to minus 4D0 RBP. This will be the bottom of our stack. Secret 1 is going to be at minus 450. All right, so we have minus 450 RBP is our secret 1. Flag at minus 490. finally minus 4D0 here for secret 2, which is right at the bottom of the stack. So that's right there. Our buffer is going to be up in here. But honestly, we don't really have to worry about that. We're not taking over the return address. For completion's sake, we'll go ahead and we'll read through, see where that buffer is being read into. So that's called in the scanf. And as you see, it's the second argument here, which means that we should be looking for it in the RSI register. So if we go ahead and we look for the scanf call, here it is. It's read into EDI, RSI's complement. Here it is, actually. Read right into RSI. My bad. I read that wrong. So it's read right into RSI, where we expect buff to be anyways. So perfect. We're ready to go. And that's going to be at minus 410. And the buffer is of size 1024. So that's equal. What we want to do is we want to read off this flag variable, right? And our RSP is going to be incrementing in little blocks of 8. So we need to know what we're doing, RSP plus what number, in order to get our flag, or the start of our flag. From secret 2 to flag, we have that's 4D0 minus 490, which I can tell you is OX40, which is what we would expect given that this is 64 bytes for the secret here. So it's OX40, which means that we have 8 blocks, right? Because if we're dividing this by 8, that'll again give us 8, right? 64 divided by 8 is 8. So that means that we have 8 blocks there. So what we're looking at is RSP plus 8. Right? We want RSP plus 8. Now what argument is that to our printf here, right? Or sorry, RSP plus 64, right? What argument is that? That's going to be 8 more because these are increments of 8, right? So we can go ahead and rewrite it all out if we want. But instead of doing that, we can say, okay, RDI, that's not the first one. This is the first one, RSI, right? That's going to be our first command or argument. So we have 1, 2, 3, 4, 5. Then we start the stack, right? Each 16 is going to be 2. So on top of this 1, 2, 3, 4, 5, we add 8. So 8 plus 5 should be the 13th argument. I'll go ahead and do all this out. I mean, just to prove it to you. Now and count them. Starting at 1 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ooh, counted wrong. Glad we checked. So that's the 14th argument. All right, I guess we want to start at plus 64. Now, the flag may not be that long. It might be more than just one block, so we're going to need to read the next block in sequential blocks. All right, so essentially what we do is we will read it as hex using our command lx, right? And instead of having to spam this 14 times, we're actually provided a useful thing, and we can do this number, 14 lx. That'll grab the 14th argument that we pass into printf and then return it as a long hex. Our flag is going to be printed in reverse order. I guess this is PicoCTF, so the flags all look like this, something like this, where this is our actual flag value in here, and this is what we're looking for. But the P will be right at plus 64. Plus 65 will be the I, C0, CTF, right? It's stored in little endian form. So what we need to do is go ahead and find our exploit for this. So I'll go ahead and build it out here. We'll use Python because that's easy. It's a great scripting language. Let's go ahead and let's look at it first, right? So we'll mark this as executable. I trust PicoCTF. And then our flag, we will call it just flag. This is a secret. 1, 2, 3. So running again, we'll go ahead and we'll look at the 14th argument on the stack, and we have this. Now, we don't really know what this is, but we know that it should be the hex value of our flag. If we go ahead and we look hex to ASCII, we go ahead and put that in there. There we go, flag backwards, FLAGTH. So that would be the start of it, right? So now what we're going to do is we're going to read all of the blocks, right? All 8 of them. Our format string will be for I in range, and we'll just go for 8. And we'll build out our offset here. Our offset we know is 14. We calculated that before, although I did the math a little bit wrong before. and we'll go ahead and we'll say we will just print percent this I plus offset, and then LX. We need to make this a format, and then we'll end it with a period, just so that we can like separate them. We'll script it up better in a second, but just for proof of concept. And then we will go ahead and we'll run that. Now if we want to just paste this in, oopsies, can't paste that in. Our order is going to look like this. We'll look at it, and obviously it won't all be the flag, but some of it will just be nonsense. So here it is, and if we read it backwards, you'd probably get it right. Sometimes it shortens these. We have our flag here, and it's actually just in these first 3 blocks. But essentially what we're going to want to do is read through all the blocks, print them back out. So we'll go ahead and we'll use subprocess. It's a useful tool here. Our binary is going to be format string 1. We'll go ahead and we'll import subprocess. And then we need to be passing it into the standard in, so we can take care of that pretty easily. All right, so using subprocess, we're going to be able to test this format string vulnerability. So we'll go ahead and we'll say our process is going to be subprocess.run, and we'll go ahead and that'll be our binary, the first argument, and then our input will be our payload, which we need to build out, and then our standard out is going to be subprocess.pipe, and finally standard error subprocess.pipe, just in case we get that. I mean, it's just a good test. So we have our subprocess here. We're going to run it on the binary, but we need to build out our payload first. Our payload will look something like this, right? We'll just go ahead and separate each one, and we'll go, because this is the block, right? So the flag size is 64 bytes, and then our block will be 8. And now we have our flag size divided by our block size. This needs to be an integer, and our payload will be equal, we'll just start appending this on. And then finally, what we'll need to do is encode it. Okay, now that we have this, we're going to need to get the data out, right? So in order to do that, we'll get our standard out, and then we'll decode it. But yeah, we'll decode it. And then we'll split it based on, actually we won't decode it. We'll split it based on these dots that we've put between, because those should print out the same, just putting them after our LX. We'll say that our payload is going to be this payload, just so that we can look at it again. And finally, when we split here for block and this, we'll go ahead and we will first split the block into characters, right? So characters, and we'll start our flag off here. Characters are going to equal this block and spots of 2. Now just printing out characters, make sure that we did that right. So we're going to need to split by lines. So we'll go ahead, we'll call dot split lines, and we'll go ahead and we'll grab the second one, and that should just give us our data that we're asking for. Yeah, here's your order. All right, and then we'll go ahead and we'll split on the colon here, grab the second part of it. Oopsies, missed something there. All right. Right, and that's the data that we actually wanted to extract. So we'll go ahead and we'll just save this. This will be our output. It's going to be that. We'll break on this output dot split on dot. Right, okay. Now we've got it going. So we're going to need to grab try and range the length of the block to 2. Sorry, we'll start from 0. Length of block increased by 2. Now sometimes we're giving these things where they're not exactly right for the block, so we'll say if the length of the block does not equal, and our size should be 16 here, 1, 2, 3, 4, 5, 6, 7, 8, so it should be 16, right, because that's 2 characters to represent each byte. Then we'll go ahead and we will add a 0 onto the front. Sometimes it's or 0 times the length of the block. 16 minus the length of the block. 16 minus the length of the block plus the block, and we'll go ahead and add that together. Sometimes it has these things where it doesn't really put them out all the way, and we want to be able to be working with these 8-byte objects every time. Perfect. So now we're going to go through, we'll grab each character, and we'll add it to our process here. So what we're going to do is we're going to work our decoded block is going to be nothing. Then we'll go ahead and we will go into here, grab each one. Now we have our hex value is going to be our block from I to I plus 2. I had an extra indent here. And then what we can do is we can interpret our hex value as an integer, base 16, and go ahead and decode that. Actually, this is character. So we're calling char on it, and then we'll go ahead and add it to our decoded block. And we can go ahead and at each end, we'll print out the decoded block, but it should still be backwards. Perfect. Now we have our decoded block. Again, it's flipped backwards, so what we need to do is at the end of each one, we will just go ahead and go, actually before this, we can just strip up here. Makes the code a little bit neater. We don't need to print out our blocks anymore. Now, to our flag, we are going to add our decoded block, but backwards. And then at the end, we'll print, here is the flag, and our flag. And of course, we need to make this a format string. Perfect. Now we get the flag. We really only want until the brackets. Our flag is going to be our flag, up until our flag where we find this close bracket. And then obviously +1 because we want to include it. Perfect. There's our flag now. We've got it all perfect, just the way we like it. All right. Now, instead of running on our local machine, what we need to do is we need to make this run on the other machine that we're targeting so that we can get the actual flag for this vulnerability. So we'll go ahead and we'll go into socket instead of subprocess, and our payload's going to stay the same. But this time, we will call our socket, make a socket, finet, and then sock stream. Now we'll connect on a host and port that we specify. Here we'll go ahead and we'll say that our host, instead of our binary, because we're not using that anymore, our host is going to be this, whatever we netcatted to before. It'll be Mimos Pico. So go ahead, go here. That's our host, and our port will be right here. Now what we'll do is we will read the data because they send us something first. Decode that and we'll just print it out. And then we'll go ahead and we will send our payload here. and we will send our payload plus a little end character so that it's encoded correctly. Make sure that we encode this too. And then we can go ahead and we can read again. And this will be our output. Output will be this, and instead of process.standardout, we will have output here. So just go ahead and instead of this line and this line, we will just have our output is going to equal our output. All that. All right, we have to code twice. Alrighty, so now this should work just fine. We'll go ahead and we'll test this, make sure that it works. We have a little problem here. Must not be reading incorrectly. So we'll go ahead and we'll print out our output. So we do have it here. Here's your order. It gives us the flag that we're going to be reading. Our problem is we decode it, we split lines. We get it a little bit different here this time, right? So we have the colon here, and we're looking for not after the first line, but we want the first line of the output instead of the second line. So that should work now. And now we have it. PicoCTF. Here's the flag. Go ahead and put that in. See that it works. Bang! Hurrah! We solved this challenge, and we earned ourselves a couple of points there. I hope you learned a little bit something about the way that the computers work, how the x86 instructions take in values, take in arguments and assembly, and hopefully a little bit about the way that format strings can be leveraged for the vulnerability.